What is up, guys? Welcome to JEDL Science. Here are your hosts, Jaden, Professor Daniel, Test Subject Leon, and who can forget our favorite hamster, Eddie. Today we'll be explaining the Millikan oil drop experiment. You may ask, what is the Millikan oil drop experiment? Why was it created? Who created it? And the main thing, the physics behind it. Well, you've come to the right place. This can be a hard concept to understand, so stay tuned as in this video we'll be covering some major dot points. Also, we'll be guiding you through our introduction, important background information of the experiment and the physics behind it and how it works, which you will get a better understanding of this experiment. If not, I hope you guys gain something from watching this. Tune in and enjoy.
Guys, let's start off what the MILIKAN oil drop experiment was. The experiment was performed by two scientists in the year 1909, Robert Millikan and Harvey Fletcher. They wanted to measure the charge of an electron. Why though? Before the experiment was even created, the existence of subatomic particles was not universally accepted. This meant people argued about the reality of subatomic particles. Performing the experiment, they proved that the electric charge is quantized.
How did they prove their theory of determining the charge of an electron? To determine the charge of an electron, Robert Millikan and Harvey Fletcher both used small droplets of oil and then suspended them in mid-air using only gravity and electricity. Using this technique, they were able to find out how much charge each electron had. It's amazing, really.
You guys may question how this experiment was performed. Well, a pair of parallel horizontal metal plates were used, the bottom being positively charged and the top being negatively charged. Being hooked up to a power source and by applying potential difference across the plates, an electric field was created in the space between them. A ring of insulating material was used to hold the plates. 4 holes were cut into the ring, 3 for illumination by a bright light and another to allow viewing through a microscope. A fine mist of oil droplets was sprayed into the chamber above the plates using an atomizer, which acts like a perfume sprayer, but instead of perfume, it's oil droplets. Imagine using this as an actual perfume.
The specific oil droplet was chosen because it had an extremely low vapor pressure. Ordinary conventional oil would evaporate under the heat of a light source, causing the mass of the oil drop to change over the course of the experiment, which is not reliable. Now let's take a look at the experiment again. Some oil droplets become electrically charged due to friction with an atomizer as they are sprayed through the nozzle. Alternatively, charging could be brought about by including an ionizing radiation source, but that's another story. The droplets entered the space between the plates, and because they were charged, it could be made to rise and fall by charging the voltage across the plates. So now we know how it was done. We must question ourselves why.
Well, why do we have it, I hear you say? Well, it is an essential part in measuring elementary electric charge of an electron. It was revolutionary in the world of physics to calculate that there was a smallest unit of charge or that the charge has a prescribed set of values. That's insane. This was so cool he even received a Nobel Prize for it. What a smart guy. It settled a long held debate on the existence of subatomic particles. This proved that electric charge is in fact quantized.
Have you ever wondered how the liquid in link sprays and perfumes are transformed into a mist form? Well, it's all behind the physics theory of atomization. Atomization refers to the separation of something into finer particles. It is a process of breaking up bulky liquids into droplets. Enthalpy of atomization is the amount of enthalpy change when a compound's bonds are broken and the component atoms are reduced to individual atoms.
Enthalpy, meaning the thermodynamic quantity equivalent to the total heat content of a system, is equal to the internal energy of the system, plus the product of pressure and volume. With electrostatic atomization, the electrostatic forces are used to atomize the fluid. In electrostatic spray charging, the spray is usually atomized by airless, air spray, or rotary means. An electrostatic charge is then applied to the droplets as they form to help attract them to the work surface. Basically, enthalpy or atomization is the amount of enthalpy changed when a compound's bonds are broken and the component atoms are reduced to individual atoms. How do the droplets getting pulled down work? Well, when lowering the droplets downwards, you can either switch off electric field and just let the droplets fall, just like anything else, at free fall due to the effect of gravity.
Whoa! Upwards and downwards? What a trip out, right? Well, let me explain. When the oil droplets are between the parallel plates and are charged, the voltage is controlled across the plates for the experiment. The droplets are able to fall between the plates when the electric field is turned off, but if the electric field was turned on, the charged droplets will start to rise if the electric field was big enough.
This is because of the physics of upward force when the electric field was turned on. As long as the force of the electric field is greater than the force of gravity, the droplets will rise. What? That's crazy, y'all.
So, how exactly did Millikan suspend the droplets in mid-air? It wasn't magic, it was science. Millikan would change the voltage between the plates before starting the experiment. He had total control. During the experiment, a voltage generating the electric field was applied between the parallel plates and were adjusted until the droplets were suspended in mechanical equilibrium. This was like a game of tug-of-war, where the rope is kept still because the forces acting against each other are equal. When the oil droplet was suspended, the gravitational force was equal to the electrical force. This allowed Millikan to obtain different values of charge in a single droplet, which was the whole point of this experiment. The whole experiment was well executed.
So, what is discrete charge? What are the physics behind it? Given there are two charges in test charge, the test charge feel a force by both charges. There are two forces, one pushing and one pulling. The electric charge created by the two charges will be the sum of electric fields created by one. Adding these two, we can find direction. The definition of discrete charge distribution roughly means at precise location.